Today we face one of the most significant challenges of our time: environmental collapse. It's a crisis that demands immediate action, and one of the ways we can respond is by finding sustainable transport solutions. Solutions that reduce CO2 emissions without contributing to deforestation or humanitarian atrocities. This is where Veggie Motor Project comes in. Our project revolutionizes the personal transport sector by enabling a diesel engine to run exclusively on discarded vegetable oil. Why continue the use of combustion vehicles instead of switching to EVs or hydrogen? Well, there are 4 main reasons. The first, social impact. A typical EV has 14 kilos of cobalt, 70% of which comes from the DRC, Democratic Republic of Congo, where 38 people a week die in collapsed mines. Number 2, life cycle assessments reveal that electric vehicles, quote from the Journal of Cleaner Production, transfer environmental burdens from the use phase to the raw material extraction and manufacturing phases. It entails a delocalization but not disappearance of socio-environmental issues. For example, EVs' use increase marine exotoxicity by 41% relative to petrol vehicles. Number 3, EVs might have zero tailpipe emissions, but disregarding production and electricity generation impact is misleading. EV production creates between 12,000 and 20,000 kilos of CO2. Because our project works with used engines, there are no production emissions. The manufacturing of our system contributes less than 1 kilo of CO2. The burning of vegetable oil creates around 0.2 kilos of CO2 per kilometer. Likewise, current electricity dependence on fossil fuels still creates 0.1 kilos of CO2 per kilometer driven for an EV. Number 4, what do we do with the millions of diesel vehicles on the road today? Scrapping them would be a vast waste of resources. By using vegetable oil as a fuel source, we can continue to use vehicles that have already been manufactured, without depending on the continued extraction of fossil fuels. Here in Canada, oil extraction from Albertan oil sands is, quote, one of the most environmentally degrading processes humankind has ever perpetrated, end quote, creating toxic tail ponds visible from space. Waste vegetable oil is a renewable resource that is a waste product from the restoration and fast food industries. As living costs continue to rise, our fuel source has zero cost as restaurants usually pay to discard it, alleviating the financial strains of the average Canadian family who spends over $280 a month on gas. In addition, the global market for alternate fuels is projected to experience significant growth, already an additional $100 billion in the period of 2021 to 2022. This is not all to say that we should discard electric vehicles and other new technology. As with anything, an energy transition requires balance and realism. We propose that our project can be a stepping stone to something greater. It raises important considerations for any new technology and highlights the importance of reducing consumption through reuse. Along with other research and innovations in the waste vegetable oil and biodiesel markets, we will contribute to a more sustainable future. The Veggie Motor Project aims to build a multi-component heated fuel filtration system that allows a diesel vehicle to run 100% on used vegetable oil, without chemical treatment. Our current prototype consists of a heating system that can be integrated into a diesel engine's fuel system, allowing the engine to run solely on filtered vegetable oil while maintaining longevity and reliability.
The scope of this project was to heat vegetable oil to 70 degrees Celsius. At this temperature, the oil will have a similar dynamic viscosity to diesel at room temperature. This means that the vegetable oil can be used as a substitute for traditional fossil fuel without causing damage to the engine or its components and avoid excessive pressure buildup in the injectors. A basic viscosity test was conducted by measuring the time a metal ball takes to fall a set distance when immersed in oil at 70 degrees Celsius and less, going down in 10-degree increments. We compared the same test done with diesel. The vegetable oil we used as fuel is olive oil from Jam Jar Canteen. Here is the graph of our results, and we see that around 70 degrees, the time for both vegetable oil and diesel are similar. We also tested if our single-cylinder diesel engine we acquired from a blueberry farmer in Surrey can run with vegetable oil at room temperature. As you can see, the engine ran on used vegetable oil with no issues.
What are the components of our design? Here is a schematic of our final design, including the tank, heating system, electrical system, and engine. The fuel system consists of two primary pressure zones. The low pressure zone is between the fuel tank and the fuel pump, while the high pressure zone is from the fuel pump to the injector. A secondary fuel tank is added to the low pressure zone. This tank is made of steel welded into rectangular shape, and it can hold approximately 350 milliliters of fuel. Brass fuel line fittings are threaded into the top and the bottom of the tank, and the temperature sensor is fixed with epoxy to the inside of the tank.
Two PTC heating elements, consisting of ceramic heaters within an aluminum casing, are each attached to the large faces of a secondary tank, with high thermal conductivity paste between them. The heating elements are able to heat up to approximately 70 degrees when supplied with 12 volts. The tank and the heating elements are insulated from the surroundings using reflective insulation material with low emissivity to achieve an efficient heating time.
The electrical system of our design consists of hardware and software to read temperature in the fuel tank and control a high power system. An Arduino microcontroller is used to control a relay, read temperature sensitive through C++, and set the LCD temperature and relay's conditions. The Arduino is programmed to turn on the heating element before starting the engine. It will indicate when the fuel tank has reached 70 degrees on the LCD. The waterproof temperature sensor is used to read the temperature within the tank where the vegetable oil will be heated. A one-channel relay with a maximum load of DC 30 volt and 10 amp will act like a switch to allow the power supply to supply power to the heating element when the temperature in the sensors are below 70 degrees and disconnected when it's over that threshold. We power the Arduino and the heating element with a 12 volt computer power supply, but we plan to run the system off a car battery in an alternator system. The electrical system is housed in a water resistant case with cutouts for the LCD and power switch.
Our entire system relies on clean filtered oil to function correctly. For this reason, we drain the oil through 200 to 1 micron filters so that no impurities reach the injector. We drained and filtered multiple times in addition to letting the oil settle for a week, as you can see.
Here is a demonstration of our prototype after the tank was heated up to approximately 65 degrees for about 15 minutes.
The tank is at 61 degrees, filled with vegetable oil. Let's hit it.
The system is able to quickly reach a temperature of over 50 degrees Celsius and reliably reaches 60 in a span of 10 minutes. Although insulated, the tank's maximum temperature is heavily influenced by the ambient temperature, with a max temperature recording of 66 degrees. Starting the engine on oil is a more challenging task than with diesel. Once running, the engine's performance seems to be unaffected. It idles smoothly and it has a quick throttle response, indicating a sufficient and constant supply of oil to the injector.
For the electrical system, instead of using a relay to control high power part of the system, we use a transistor that can handle the required voltage and current because they are much smaller and faster.
For the future of this project, we hope to add a filtration system so consumers won't need to worry about filtering and only have to fill up like they would at a gas station. Since we use a computer power supply to power both Arduino and heating elements due to budgeting reasons, we hope to replace it with a car battery for mobility and scalable vehicle applications. Also, to further test our system, we intend to install it onto a fully built go-kart or motorcycle and have a test run comparing diesel and vegetable oil.